Okay, welcome to Easter Monday. We were here on, do you guys know about Easter? Yeah, weird, I know it's weird probably to you guys, but whatever, anyway. We had school yesterday, maybe we'll get comp time for all the Christians, don't have to come to school one day or something like that. Okay, anyway, right. How many Christians in here? Anybody? So I got like 3/4 of the class. Okay. You're not Diego? That's fine. It's all right. You're not Christian? Christian. Yeah, Diego wasn't listening. That's okay. It's all right. Name like Diego. Okay. Diego, how you doing? All right? You look very quiet today. Everything's all right? Yep. Yeah, cool. Are you out of the doghouse?
I don't know what that means, but I think I am.
You think you are? Okay, excellent. It's a very American expression, the doghouse. How many Americans know what that means? Are you in the doghouse? How many Americans have never heard of that?
What did you say?
In the doghouse. Are you out of the doghouse? So you know what it means?
Yeah, like go to jail.
No.
Well, no, it's not about jail. I wouldn't call it jail. Let's not get crazy. Maybe in Texas it's jail. But, yeah.
Like being grounded, I guess.
Yeah, like being grounded or like in trouble. Yeah, something domestic. Yeah, low-key kids, you're in the doghouse, you know. I used to be in the doghouse all the time with my kids and my ex-wife. I was always in the doghouse. But anyway, we're going to do a random gas problem. And the reason I want to do this is to show you how easy it is. We're just going to do a random gas problem. Mark, Mr. Texas, has chosen a random gas problem for us. Mrs. Mark, he's actually participating today, and he yelled at me earlier today. I have to tell you that, and I quite enjoyed it, actually. He did. He's smiling. He's so proud of himself that he really gave it back to me. I like it. I didn't realize he spoke English so well. I thought he was spoke English as like a second or third language. I thought he probably had an accent or something. But you do. You speak English well. Is English your first language?
No, Spanish.
Spanish is first language. Excellent. Well, you have a great. I can't detect your Spanish accent at all. Excellent. All right. So Mark. So give me Marco, I should say. Give me the problem.
The gas with the volume of 4 liters at a pressure.
All right, wait a second, hold it. Volume equals 4 liters. All right, that's all I heard. What else, Mark?
And at a pressure of 205 kPa.
A pressure of 205 kPa. I should put that as a small a. kPa, okay. All right, so are you telling me that there's a gas which has a volume of 4 liters and a pressure of 205 kPa, kilopascals. Is that what you said so far?
Yes, sir.
Okay, there's a gas under those conditions, correct? So those are initial conditions. Is that correct, Mark?
Yes.
So how would we indicate that they are initial conditions? How would we say that? They look stunned. Yes? Yeah, subscript 1. Okay, subscript 1. Yeah? All right. What else? Go ahead.
So 200 is allowed to expand to a volume of 12 liters.
So it can expand to 12 liters. So you're saying that there's a gas confined to 4 liters and that pressure, right? And that gas is allowed to expand to that volume. Is that what you're saying? Are you sure? Yes, excellent. Now, okay. So, what's the pressure going to be? Is that what you're saying? What will the final pressure be? Could you come up here? You don't have to be on camera, but could you be up here, lose the gum, and read that problem to the microphone here? Just read it. Yeah, the problem. Just read it just clearly. You just stand right here, stand right there, and just read it to the problem. Just read it normally, like you're just reading to yourself, like you're at home and you're losing your mind and you just feel like reading something to yourself.
Oh, I got
okay? Does everybody do that? Like you go home and you just randomly read to yourself? Excellent. Mark, go ahead.
The gas with a volume of 4 liters at a pressure of 205 kPa is allowed to expand to a volume of 12 liters. What is the pressure in the container if the temperature remains constant?
Excellent. Thank you. Yes, Jen.
68 and 30 kilopascals.
Jen is my little overachiever. She's a wonderful person. She wants to be, when she graduates from school. She wants to be a chemical engineer and a neurosurgeon, I think. Is that today? Yeah, excellent. Jen is a wonderful person. She gave us the answer already. You see how good she is? I mean, she's wonderful. I don't care what your mother says about you, you're great. Okay? So, this is going to be, what law is this? Who's the guy? Think burn. Yes?
Boyle.
Boyle's law. Boyle's law. Lance the Boyle. Okay? All right? So, Boyle's law, which is P1V1 equals P2V2, and then plug in. Now, you have to use the unit labels and all that stuff. What do? This is what I was having a talk with Mr. across the hall earlier, and I said, you know, as long as everything is in standard units, we're okay. Correct? SI units. If it's in centimeters, you convert it to meters. If it's in atmospheres, just convert it to kPa. Whatever it is, just convert everything. Correct? So, is everything okay? Yes? Okay. So, even though liters is not the SI, what's the SI volume for? It's actually cubic meter, isn't it? But we use liter in gas laws, don't we? Weird, huh? Okay. So, plug in 205 times 4 equals P2 times 12. What do we got? Jen? P2 equals 68 kPa. Close enough? Close enough. Excellent. So it's really that easy. It's not hard. We're going to do that problem. We're going to make one more, and then we're done. That's a good gas law problem. That's Boyle's law. Correct? Easy? Easy? Hard? Kinga, what do you think about that? It's all right? Excellent. God bless Poland. Okay, excellent. Excellent. Musaba, how you doing? Musaba just had heart surgery, and he's recovering. He's got to be very, he runs a business on the side, so he's got to take it easy. He doesn't want to, bust his stitches, so he's not very exciting today. Okay, excellent. Okay, we're off.